right, question number 9. Which equation is correct for the reaction between carbon dioxide and magnesium hydroxide? Couple of things to keep in mind. This is a base. And technically, this is a gas, but it also happens to be an acidic oxide. So when you react this acidic oxide with your base, it will in fact end up creating two products. It will create salt and it will create water, right? So the salt is what's probably most in question. Anytime that you react carbon dioxide with any hydroxide or oxide base, the salt that forms is always magnesium carbonate. So again, when you put CO2 into MgOH whole 2, you will get magnesium carbonate, you will get water, and if you look carefully, the only choice that very carefully balances out correctly is A. All right? So again, one magnesium on either side, one carbon on either side. The oxygen value is 4 on either side, the hydrogens are 2 on either side. So the equation ends up being balanced accordingly. All right, question number 10. 4 grams of sodium hydroxide dissolved in 250 centimeters cubed of water in a graduated flask. They've given you basically the concentration, and then or you can get the moles from this. A 25 sample of this solution is titrated with 0.5 molar HCl. Which volume of hydrochloric acid is required to neutralize the alkali? Now, here's the problem. The volume that they've given you and the mass that they've given you can get the moles that are present in 250 with that. But you're only using 25. So here's the catch. First things first. This is how you find the moles of your NaOH. 4 divided by 40, the MR, you get 0.1 moles. But again, this 0.1 mole is in 0.25 PMQ. Now, remember, they're only using 25 or 0.025 PMQ. So here's what you're going to have to do. If that's the number of moles in 250, then to find the number of moles in 0.025, you simply cross multiply, and you find out that there's 0.01 moles of sodium hydroxide in the 25 centimeter cube. Now, the other thing, the equation, they didn't give it to you, but you know what the ratio is. The ratio is 1 to 1, right? So if this is the moles of your alkali, this must be the moles of your acid, right? Now, we've got the moles of our acid, right? We know exactly how many moles of HCl are there. If this is the moles of HCl, now using the concentration of the acid given, we can work towards volume. So the way you do this, 0.01 into 1,000, because you've got to convert Bm cubed into Cm cubed, and you divide that by 0.50, and what you should get here is, I believe, 20 centimeters cubed. Let me confirm myself, so we're all on the same page. Yeah, so the answer should be B, 20 centimeters cubed. All right. Now, next question, number 11. I think the biggest problem here was most students just used 0.1 moles of NaOH. And so they ended up getting 200. 200 is not the answer, because remember, you're diluting 250 down to 25. So the number of moles will decrease again accordingly as well. All right, next question. Excess barium chloride is added to 25 centimeters cubed of a 1 molar sodium sulfate solution. They tell you that at the end you get 5.36 grams of barium sulfate. So your job is to deduce the percentage yield. All right. Now, this, if you remember, is given to you in the question, that's the actual yield. And given the volume, 0.025, and the molar concentration, this is the moles of your sodium sulfate. Now the ratio, between the sodium sulfate and the barium sulfate is 1 to 1. So not only is this giving you the moles of the sodium sulfate, it's giving you the moles of the barium sulfate as well. Now, since we've got the moles of the barium sulfate, the only other thing we need to do is multiply that by the MR, which is 233. So 0.025 times 233, your actual, sorry, your theoretical yield comes out to be 5.825. All right. Now, percent yield is equal to actual over theoretical into 100. So that would be 5.36 divided by 5.825 into 100. That's the way we're going to set it up. It would always, and you got to remember this, it's always the smaller value divided by the larger value. And when you work this out, you get, comes out to be approximately 96.1. We're going to go ahead and pick the 97% as our percent yield. All right, any questions there? All right, stoichiometry again, use the molar stoichiometric ratios. Mole to mole, there's a three-step approach that should always be kept. Three steps being that first, find the moles of, again, what is given to you in the question, then use the ratio to find the moles of the unknown, like I've done in either of these. And then from the moles of the unknown, you can find the mass, the volume, the concentration, or the molar gas volume for whatever that is that they want the unknown to be. Okay? All right, question 12. We start getting on to नहीं बेटा someone just asked me कि 11 का आंसर C नहीं होगा. I think the working is fairly right there in front of you. I don't believe it can be C according to that work. Okay? Let's confirm कि मेरी math सही है. Yes, sorry, I apologize. It is C. I must have plugged something into the calculator incorrectly. Thank you. So it is C, 92%. Again, use a calculator. Don't try to rush it through like I did, so you get the right answer. It is 92%. Thank you. Number 12, dilute solutions of potassium chloride and magnesium chloride are mixed together. Sample of the mixture is electrolyzed using the inert electrode. Now, they tried to throw you off of this question a little bit by telling you that there's different solutions mixed together. And then they even threw the word dilute in there. Now, the dilute only really concerns itself with one side or one electrode. See, what happens here is that, again, we know that the chlorides are going to go to the anode. And we know that the potassium, the magnesium will go to the cathode. And what you guys can't forget is that the H plus will go to the cathode and the OH minus will go to the anode as well, accordingly. So that's where each of the electrodes end up going. So if that's the case, if that's what we're going to see, then what we need to be able to understand is fine. That means at the anode, I've got a bunch of chloride and hydroxide ions, but the solution is dilute. And if the solution is dilute, then chlorides cannot take preference. The only way the chlorides would ever take preference is if they are concentrated. So it cannot be chlorine at the anode. It has to be oxygen. Now, in the case of the cathode, any member of group 1, group 2, or even group 3 will never leave an aqueous solution because they're way above hydrogen in the electrochemical series. They're way above. So the ability to discharge them is almost impossible. So this will have to be hydrogen at the cathode. So the answer should be C. If you'll just give me 1 moment.
Sir, are you there?
Vijay, I'm here.
Okay.
I'm here. Okay. Question number 13. Simple, straightforward, not complicated. and the word that kind of gives everything away is this. If it's a molten electrolyte, doesn't matter what the electrolyte is, the metal will always go to the cathode, the anode will always go to the anode, and the anode will always oxidize your nonmetal, and the cathode will always reduce your metal. So, the, and if you remember, some of you may remember this. I've given a mnemonic to some of my students that is easy to remember. An-ox red cat. Oxidation anode, reduction cathode. All right. So if I'm looking at the anode, I want to show loss of electrons, and that is again either A, B, or C. B is out of the way. At the cathode, I want to show a gain of electrons. Now, the next question is specifically which equations would be correct here. Now, because it's simply a system, Ag can never be 2 plus, so let's eliminate A. Now we're left with either B or C. Now the question is this, that if I look at B very carefully, one of them shows the bromide ions incorrectly at the beginning of the equation. Bromide ions will never exist as Br2 minus. They're group 7 elements. So the maximum charge that they can hold is a negative 1. So that means it can't be B, and therefore it has to be C. Two bromide ions will oxidize into bromine at the anode. One silver ion will reduce into silver at the cathode. Now, some of you may be thinking, so the electrons are not balanced. It didn't matter here. They just wanted to see how each ion would change at each respective electrode. Now, had you been writing a complete equation from this, yes, then if there's two electrons lost at the anode, there would have to be two gained at the cathode. Someone is asking why A is not the answer, because it's Ag2 plus. There's no such thing as Ag2 plus. Silver, look at every one of the compounds that you have. Silver chloride, silver nitrate, the ratios are always 1-to-1 with nitrate minus 1, chloride minus 1, bromide minus 1, iodide minus 1. That's because silver itself is a plus 1 cation. Okay? All right, question number 14. Concentrated aqueous copper 2 sulfate is electrolyzed using copper electrodes. They want to know what would be happening at the cathode. So, first things first. I technically don't need that word at all. It doesn't really need to be concentrated, but nonetheless. Secondly, I know that this is not about the sulfate or the hydroxide, because all of those things end up at the anode. So this is specifically about your copper 2 or hydrogen, which go to the cathode. And again, if we remember correctly, of all of the cations that are below hydrogen on the electrochemical series, copper is one of those few ones. Copper, gold, silver. So because copper is lower down, it will be the one that will discharge in preference to the hydrogen ions. And because it is reduction at the cathode, the electron should be on the left-hand side of the equation, the reactant side. The answer is D.